Okay, so for our module 11, we will discuss about what you call the omitted measurements. So when you say omitted measurements, there are times that if we are going to do our field work, say in order for us to plot a closed traverse, there will be times that due to certain reasons, say for example, there are unavoidable obstructions, so we can't get the lengths of certain sides of the traverse or bearings of certain sides, so we could actually deal with it analytically, but it's not all the time that it is advisable to do so. As much as possible, we could get all the data that we need, but if there will be a time that we can't avoid having a missing data, then we will just deal with it analytically. So there are different cases of omitted measurements or missing data. Okay, we have omitted measurements are in one side. So let's say the missing data is the data about one side of the traverse, wherein the both the length and the bearing of that one side is unknown. Next case is involves two adjoining sides. So one case of that is the length of one side and the bearing of another side is unknown. Okay, and the second case is for this main category is that the lengths of two sides are unknown, and last case for this one is bearings of two sides are unknown. We will just not discuss the third main case because it's I believe that you could if in practice you could experience such missing data, then I believe you could deal with it out of what you will learn from these two main categories. So first, let's have the simplest case. So this one, we have this illustrative example. So given the following sketch and tabulated data for a closed traverse, determine the length and bearing of the unknown side FA. So the let's say for example we already have the data, and then we already have done a sketch out of our data, but unfortunately we have an unknown data, which is data about line FA, wherein both its length and bearing is unknown. And then let's say for example we already have computed the latitudes and departures based on the data that we have, okay, right here, and I believe you already know how to get the latitudes and departures of certain lines with given lengths and bearings. First solution is in getting capital CL, total latitude correction. So we just add up the summation and north latitude and south latitude. So in this case, you have 1001.6 plus negative 529.77. So we have positive 471.83, and we do the same thing for correction, total correction for departure. So we'll have this one negative. So therefore, simply our length of line FA is the square root of CL squared plus CD squared. So we have length of line FA being 710.88 meters. Okay, and then its bearing. So you are already introduced with this formula. So we already have the bearing to be 48 degrees 25 minutes, and its direction is southeast. Okay, so south, because for departure that's CL is positive. If we multiply that with negative, it becomes negative. That's why it becomes south. And for the departure, okay, CL is actually negative, and you multiply it with negative, it becomes positive. So positive means east departure. Okay, second solution, okay, that the summation of all the latitudes should be equal to 0. We already know that if a traverse is closed or does not have a linear error of closure, then if we sum up all of the latitudes, that would be equal to 0. So if we will add all of the latitudes from the line AB up to the line FA, that should be equal to 0. Now, out of this equation, we will be able to get the what should have been the latitude, what should be the latitude of line FA, so that all of this becomes 0. So in this case, you have the latitudes, you have 173.78, okay, 173.78 plus 549.3 plus 197.51, minus 197.51 plus 278.52 minus 332.26 plus the latitude of FA, which is unknown. They should all be equal to 0. And from that equation, we have learned that the latitude of FA should be negative 471.83 to make this equation equal to 0. Or this expression, all of the latitudes equal to 0. The same thing we do for departure, that if we add them all up, it should be equal to 0. So in that case, the departure of line FA should be positive 531.72. Okay, and then the length, we know, okay, the latitude squared plus departure squared, square root of that, that's 710.88. And then you have the tangent of the bearing of line FA. You simply have that departure, actual departure of FA, that will make this equation true, which is positive 531.72, and then the latitude, which is negative 471.83. So we have this bearing, and the formula would be southeast, the direction rather southeast, because for latitude negative, that means south, positive, that means east, positive departure. Okay, you may be confused as to why in this first solution we have to multiply each of CD and CL with negative, and the result will be our basis for the direction of the bearing. Well, in this solution, we don't have to multiply them to negative. Okay, bear in mind that again, when we sum up all of the latitudes, if we mean closed traverse or no linear error of closure, that means all of the summation of all latitudes with their corresponding signs, negative being for south and positive for north. If we add them all up, they should be equal to 0. Now, what happened is when we add all the available north and south latitudes, the result is positive 471.83. It only means that the missing latitude for the line FA should be negative 471.83 to make it equal to 0, to make addition of all the latitudes equal to 0. The same thing with the total correction for the departure. If we add this all available departures and the result is negative 531.72, that means that the departure for FA should be positive 531.72, so that adding this becomes 0. Okay, that's why here we have to multiply each with negative sign. Okay, so that is one of the cases, the simplest case, which is the missing data is the data about a line, missing data of a line where both its length and bearing is missing. Okay, so I guess we'll have to move on with another case. So before we move on with the second major case, wherein it involves adjoining sides. When you say adjoining, meaning the data of the two missing sides are adjoined or adjacent. Magkatabi sila. So, for that, I would like to review you with what you call the sine law and cosine law. So, trigonometry. So, if we have, say, an oblique triangle, and it has a length of the sides represented by capital A, B, and C. So, meaning this side has a length represented by capital A, and then this one capital letter B, and this one capital letter C. And so length A has an opposite angle in this vertex. Let's say we represent this angle to be angle alpha, so the opposite the angle of the opposite angle of side A is angle alpha, and for B, this will be the opposite angle, so that will be represented by beta, and for C, opposite angle is this one, that will be represented by phi. Okay, so for sine law, okay, the ratio of the length of one side to the sine of its opposite angle is equal to the ratio of another side to the sine of its opposite angle. So in this case, let's say the length A over sine of its opposite angle, which is alpha, is equal to length B over sine of its opposite angle, which is beta, and it's also equal to length C over sine of its opposite side, phi. For cosine law, you have, let's say, square of one side, let's say square of side A, the length A, equals the sum of the squares of two other sides, B and C, minus 2 times the product of the two other sides, which is B and C, cosine the angle opposite to the length right here. So in that case, angle opposite to A is alpha. So you have cosine alpha. For B, so you have B squared equals length of other two sides, you have A squared plus C squared minus 2 times A times C cosine opposite angle of length B, which is beta. For C, so we have C squared equals A squared plus B squared minus 2AB cosine opposite angle of C, which is phi. Okay. We could also use, it depends on the situation. If we need the length, we could use this one for the cosine law. If we need the angle, we could use this. So this is just actually from here. Okay, so you have the cosine of a certain angle of a vertex in the oblique triangle is equal to the sum of the squares of the sides not opposite to it. So if your angle, let's say angle alpha, its opposite side is A, then right here you have B squared plus C squared minus square of its opposite side over 2 times the two numbers here. So we have BC, and cosine beta equals K, square of the lengths of its not opposite sides. We have A and C. So A squared plus C squared minus square of the length of its opposite side, that's B squared, over 2 times A times C. And for cosine alpha, we have A squared plus B squared minus C squared over 2 times A times B. You just have to remember that at the numerator, what you will subtract is the square of the length of the side opposite to this angle. Okay, so let's have our first example. Okay, case where length of one side length of one side and bearing of another side is unknown. Okay, this one. So given the following sketch, don't worry, maybe I'll be giving you a photocopy of this one so that you could review. But anyway, given the following sketch and tabulated data for a closed traverse in which the length of DE and the bearing of EA have not been observed in the field, determine these unknown quantities. So let's say we already have this data. This is our observed data. Unfortunately, for line DE, its length is unknown, and its adjacent side, which is line EA, its bearing is unknown. So how do we deal with this? So this falls under this case, okay, where length of one side and bearing of another side is unknown. Okay, so let's say we are to plot this available data. So let's say this is now the plot. Okay, so line AB, BC, CD, and we have line DE, okay, where the bearing is known, north 28 degrees 39 minutes west. So let's say this one. This is 29 degrees, 28 degrees 39 minutes, then northwest. Okay, unfortunately, we don't know the length. And then for side EA, okay, we know its length, but we do not know the bearing. So in this drawing, we could see that we assumed that the bearing is, forward bearing of EA is north, what you call that, north east. Okay, so it's safe to assume for the bearing. Okay, so what we need is we need a closing line, okay, that we could connect, okay, out of what is the data that is available, wherein that closing line will form a triangle with those two sides who have unknown data. Okay, so this will be our closing line. Now, with this closing line, it is a closing line for this traverse A, B, C, D, and E. And we know that the lines A, B, B, C, and C, D have available data, and if we are to close that, okay, we could get the length and the bearing for this closing line. How do we do that? You already know how to. Let's say we already have the latitudes and departures for every line with the complete data, both the length and bearing. Okay, so we need AB for this traverse AB, BC, and CD. We need the length and the bearing of this closing line. We just add the north and south latitudes of AB, BC, and CD. Okay, if we add them all up, what should be the length or the latitude of this closing line so that it will equate to 0. Okay, so in that case, we'll have the north, summation of north latitude plus south latitude. We have for north, we don't have, okay, but for AB, so we have this 265. For BC, we have negative 1054.14, and for CD, this one. So if we add, we have negative 2,283.03 meters. Meaning that this closing line should have a latitude of positive 2,283.05. So that if we add all of the latitudes for this closed traverse, it will be equal to 0. The same thing goes for CD. Okay, so we add them. CD, departures of A, B, B, C, C, D, and yeah. So add na to. Okay, the result is negative 569.81. That means that the departure of this closing line AD should be positive 569.81 para maging 0. So we'll have the length now of DA. Remember, we are still focusing on this closed traverse. We are not yet including this one. Kani lang sa kani. Okay? So therefore, the length of DA will be its latitude squared plus departure squared, then square root of that. So this is the length of the closing line DA. Okay? Okay, next for the bearing, so multiply na to og negative for the departure and latitude. So we both have positives. We know that both the latitude and departure of line AD should be opposite to this sign, so they should both be positive to make this equal to 0. So in this case, you have now this one. And therefore, the tangent of DA, bearing rather, is 14 degrees 1 minute. Okay, and the what do you call that? The directions is north, positive latitude, and east, positive departure. Okay, so now we already have the data for this line. Okay. we will now focus on this triangle. Okay, so here we will be isolating the drawing for that, and we will input all of the data that we already have. So we have computed or analyzed that the length of AD is 2353.08 out of this solution right here, and its bearing is forward bearing DA. So here that's north east 14 degrees 1 minute, and backward bearing southwest, so 14 degrees 1 minute. Okay, we know the for the line DE, it has a given bearing, so we will be putting it here. Bearing is 28 degrees 39 minutes northwest, so forward bearing. For this will be for the backward bearing, and for EA, it does not have a bearing, okay, but we know its length, so we will be writing it here. Okay, so this is the available data for EA, its length 1738.96. So how are we going to deal with this? Okay, first of all, it's a skill in knowing which of the equations from the sine law and cosine law should we use to get what we want to determine. Okay, either it's an angle or a length. So in this case, if we look at the solution right here, we could actually use sine law. But before that, we will first try to get the lengths. We're in this one and this one, but we don't have a length right here, so this is unknown. And then we have to also get the interior angles of this triangle. Okay, maybe I'll just have to redraw sana ko So we'll have here this side, medyo gi-exage lang nako. Okay, okay, and we have here. So this is side D, station D. Then we have station A. Okay, so we already know that this is 14 degrees 1 minute. This is also 14 degrees 1 minute. This is 28 degrees 39 minutes. Then the length here is 2353.08. Okay, 1738.96. And then here we'll have, this is station E with the bearing, unknown bearing. So let's say this is bearing beta of line EA. Okay, and we know that this is also 28 degrees 39 minutes. Okay, so we can't get the angle right here, because if this is missing, this is also missing, this one. Okay, because this angle is equal to this angle, the bearing right here. So since this is missing, this is also missing, we can't get the angle right here. So we will still have to solve this one analytically, but we could actually get the angle right here. You'll have, okay, 28 degrees 39 minutes plus 14 degrees 1 minute. So this is 42 degrees 40 minutes. Okay, and the bearing also right, the angle also right here could not be defined because this is missing. Again, this is missing, but we all have a angle right here. Okay, so one of the sides is known, this one, let's say, but its opposite angle is not known. But we have a side wherein this length is known and its opposite angle is also known. This could actually help. Okay? So we could actually use sine law. Okay? We have a partner, this side and this opposite angle. We have 1738.96 over sine of its opposite angle, which is 42 degrees 40 minutes. That will be equal to the length of this side. Let's say that's 2353.08 over sine of its opposite angle. So for this side, its opposite angle is this one, which is unknown. Let us just name it, what could we name this? M, angle M. Okay, so we have sine of M. So we could now get sine of M. Sine of M is, so we have 353.08 sine of 42 degrees 40 minutes over 1738.96. So M is the arc sine of this quantity, 2353.08 sine 4240, 1738.96. So M angle, which is the angle opposite to this line, is equal to, okay, so we have 2353.08 08 rather, sine 42 degrees 40 minutes over this length 1738.96. That's to make it degrees minutes seconds, we'll have 66 degrees. This is 66 degrees 30 minutes and then 28.14 seconds. Okay, since this is now known, we could solve this one. Alright? Okay, again, this is 66 degrees 30 minutes 28.14 seconds. In that case, the bearing EA is equal to, so you have this whole angle, okay, this whole angle, this is 180, then minus this angle 66 30 28.14, then minus this angle 28 degrees 39 minutes. So what is left is this unknown angle. That's 180 minus, minus 66 30 28.14, 66 30 28.14, 2839, 8450 minutes 31.86 seconds. Therefore, the bearing of this line EA is already known to be 84 degrees 50 minutes 31.86 seconds. Since this is less than 90 degrees, therefore we are correct with our assumption that the bearing of line EA is in the direction north east. If in case lang na we got an angle for bearing of EA to be greater than 90 degrees, meaning andito na siya na quadrant, nasa southeast na siya. So, ang maging bearing niya is 180 minus the angle. But since less than 90, so tama na ito, nasa north east. So, this is the forward bearing. Okay. Ba ko? Sigmali ni dire. Okay, tama siya. Yun siya. Okay? So, mas exact lang ko na ako'y degrees. Anyway, wala pa ta na human, no? Because we still have for this line, kompleto ng ating data, meron ng bearing and length. But for this line, meron siyang bearing, pero wala pa siyang length. So, pwede natin kunin ang length. Pwede pa rin ang sine law. Let's say this length is length of line ED. So, that's, let's say, ED. Okay? That's unknown. So, we could use sine law. Okay? Sine law, we have a known side with the known opposite angle. So, still, we have 1738.96 over sine of opposite angle 40 to 40. Then, we have the length of this side, which is unknown, that's ED, over sine of its opposite angle, which is this one. Okay. Wala tayong angle dito, but we already have the angle here, which is this one. That's also equal to the angle right here. So, maybe we should use another color. So, this angle is the bearing of line EA, which is equal to 84 degrees, 50 minutes, 31.86 seconds. So, therefore, the angle here, interior angle right here is, if this is 84, 50, 31, 86, and this is 1401, therefore, the angle here is 84 degrees, 50 minutes, 31.86 seconds, minus 14 degrees, 01 minutes. Okay, we'll have, nalata, that's one ta, minus 14 degrees, 1 minute. So, that's 70 degrees, 49 minutes, 31.86 seconds. So, that's the angle here. Opposite angle of line ED. So, we could now have sine 70 degrees, 49 minutes, 31.86 seconds. We'll have length of ED. That's, diretsuin ko na. Arc sine of, dili pala arc sine. Okay? Ilipat lang to dito. Okay, so we have 1738.96 sine of 70 degrees, 49 minutes, 31.86 seconds. Okay, over